Canned tuna is one of the most widely consumed seafood products on the planet. A shelf-stable source of protein found in supermarkets, emergency kits, restaurants, and pantries worldwide. It may look like a simple metal can filled with flaky fish, but behind every can lies a massive global industrial system involving ocean fishing fleets, refrigerated logistics, precision processing plants, high-temperature sterilization, automated filling lines, and strict food safety controls. From the moment tuna is caught in open waters to the instant a sealed can rolls off a production line, the process is engineered for safety, efficiency, consistency, and scale. And today on The How Factory, we're going deep inside the factories and facilities that turn raw ocean catch into canned tuna ready for supermarket shelves around the world. The journey begins far from land in some of the most productive fishing zones on Earth. Tuna fishing vessels operate across vast ocean regions, targeting species such as skipjack, yellowfin, albacore, and bigeye. Modern tuna boats are floating industrial platforms equipped with advanced sonar, GPS tracking, and fish aggregating detection systems that help crews locate schools efficiently. Once a school is identified, nets or lines are deployed and the catch is hauled aboard. Speed is critical from this moment on. Tuna quality depends heavily on rapid handling. As soon as the fish are landed, they are sorted by size and species, then immediately chilled or frozen on board using blast freezers or refrigerated seawater systems. This rapid cooling prevents spoilage and preserves texture, color, and nutritional quality. Once holds are full, vessels return to port or transfer their frozen catch to refrigerated carrier ships. The tuna then enters the cold chain logistics network, remaining frozen at carefully controlled temperatures throughout transport. Any temperature fluctuation can compromise quality, so continuous monitoring systems track conditions during transit. At the processing plant, shipments are unloaded under strict inspection. Each batch is logged, weighed, and sampled to verify species, condition, and temperature before entering production. Inside the processing facility, the frozen tuna moves into controlled thawing rooms. Thawing is done gradually using chilled water or air systems to prevent damage to muscle fibers. Uneven or rapid thawing can cause texture breakdown, so this step is carefully managed. Once thawed, the fish move to preparation lines where the industrial transformation begins. The first major processing step is cleaning and butchering. Workers or automated systems remove heads, tails, fins, and internal organs. The tuna are then split and washed thoroughly to remove blood, impurities, and residual tissue. At this stage, the fish are still raw and intact, but they are now prepared for cooking. Every surface and tool in this area is designed for food safety, using stainless steel equipment and continuous sanitation protocols. Next comes pre-cooking, a critical step unique to canned tuna production. The cleaned tuna are loaded into large racks or trays and placed inside industrial steam cookers. These massive chambers cook the fish at controlled temperatures for extended periods. Pre-cooking firms the flesh, drives off excess water and fat, and develops the texture that consumers expect from canned tuna. This step also makes the fish easier to handle during later processing. Cooking times and temperatures vary depending on species and size, and computer systems monitor every cycle to ensure uniform results. After cooking, the tuna must cool before further handling. Cooling tunnels reduce temperature gradually to prevent moisture loss or surface drying. Once cooled, the tuna enters one of the most labor-intensive stages: cleaning and loining. The cooked fish are broken down into loins, large muscle sections, while removing skin, bones, and dark meat. Dark meat, which has stronger flavor and higher oil content, is often separated for specific products or other uses. This step requires a combination of skilled workers and mechanical separators, as visual judgment is still critical for quality. The cleaned loins are inspected, trimmed, and graded. Any remaining bones or imperfections are removed. The tuna meat is now fully cooked, clean, and ready for canning. At this stage, it may be stored briefly in refrigerated holding areas before entering the canning lines. Timing remains critical to prevent contamination or degradation. Canning begins with portioning. Conveyor systems deliver tuna meat to automated fillers that weigh and dispense precise amounts into empty cans. Depending on the product, the tuna may be packed as solid, chunk, or flaked styles. Solid packs use large, intact pieces, while chunk and flake packs involve controlled breaking of the meat. Accuracy is essential. Regulations require strict weight compliance, and consistency matters to consumers. Once tuna is inside the can, liquids are added. These may include water, vegetable oil, olive oil, or broth, depending on the product type. The liquid serves multiple purposes: improving flavor, preventing drying, and aiding heat transfer during sterilization. Automated dosing systems ensure exact volumes are added to each can. Some products also receive salt or seasonings at this stage. After filling, cans move to sealing stations. Lids are placed on top and passed through high-speed seaming machines that crimp the lid onto the can body, creating a hermetic seal. This seal is one of the most critical safety features in canned food production. A properly sealed can prevents bacteria from entering and allows the product to be stored safely for years. Seam integrity is continuously monitored using sensors and destructive testing of sample cans. Once sealed, the cans are not yet shelf-safe. They must undergo sterilization. This happens in retorts, large pressure vessels that function like industrial autoclaves. Cans are loaded into baskets and rolled into retort chambers, where they are heated under pressure to temperatures high enough to destroy harmful microorganisms, including spores that could cause foodborne illness. This process, known as commercial sterilization, is carefully calculated to balance safety with product quality. Too little heat is dangerous. Too much heat degrades texture and flavor. Computer-controlled systems manage time, temperature, and pressure with extreme precision. After sterilization, cans are cooled rapidly to stop the cooking process and prevent overprocessing. Cooling also helps stabilize the internal pressure of the cans. Once cool, the cans are dried and move into inspection lines. Automated systems check for dents, bulges, leaks, and seal defects. Any can showing abnormal pressure or deformation is rejected immediately. Labeling and packaging follow. Cans pass through labeling machines that apply printed labels or direct print branding. Date codes, batch numbers, and traceability markings are added using inkjet or laser systems. These codes allow manufacturers to track every can back to its production batch, fishing vessel, and processing line if needed. Quality control continues throughout the process. Laboratories test samples for moisture content, salt levels, texture, and flavor. Microbiological testing confirms sterilization effectiveness. Shelf life testing ensures the product remains stable over time. Some samples are stored under accelerated aging conditions to simulate years of storage in a shorter period. Once approved, cans are grouped into multi-packs or cases. Automated packers place cans into cardboard trays or shrink-wrap bundles. Robotic palletizers stack cases onto pallets, which are then wrapped and labeled for distribution. Warehouse systems track inventory movement and coordinate shipments to distribution centers, retailers, and international markets. Behind the scenes, sustainability and resource management play an increasing role in canned tuna production. Processing plants recycle water used in cleaning and cooling. Fish byproducts such as bones, skin, and trimmings are processed into animal feed, fertilizers, or other secondary products, reducing waste. Energy-efficient retorts and heat recovery systems help lower fuel consumption. Many companies also participate in fishery management programs aimed at maintaining healthy tuna populations. What makes canned tuna manufacturing remarkable is how it connects the open ocean to the supermarket shelf through an unbroken chain of temperature control, food science, and industrial precision. A fish caught hundreds or thousands of miles offshore is transformed into a sterile, shelf-stable product that can be stored safely for years without refrigeration, all while maintaining taste, nutrition, and safety. From ocean fishing fleets and freezing holds to steam cookers, retorts, and automated canning lines, the journey of canned tuna is a testament to modern food engineering. Every can represents coordination between fishermen, engineers, food scientists, quality inspectors, and logistics planners working together at massive scale. And that is exactly how canned tuna is caught, frozen, cooked, cleaned, packed, sealed, sterilized, inspected, and shipped. A complex industrial process hidden behind one of the most familiar and dependable foods on supermarket shelves. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind everyday products.